Hi, I am Taputipal, student of Cogbiar Government Engineering College in the Department Electronics and Communication Engineering in 3rd year. Today I am going to give a presentation about pulse code modulation. So let's start. So firstly we need to know what modulation is. Modulation is the process of varying one or more parameter of a carrier signal in accordance with the instantaneous value of the message signal. Now let's get into the topic pulse code modulation. Pulse code modulation (PCM) is a method for digitally representing analog signals by converting them into a sequence of binary digits. Here is a diagram of sine wave input and PCM output. Next we have a block diagram of PCM. Now let's discuss about the element of this block diagram. Firstly we have a low pass filter. This filter eliminates the high frequency components present in the input analog signal which is greater than the highest frequency of the message signal. Next is a sampler. This is the technique which helps to collect the sample data at instantaneous values of the message signal so as to reconstruct the original signal. The sampler goes into the quantizer. Quantizing is a process of reducing the excessive bits and quantifying the data. The sampled output when given to the quantizer reduces the redundant bits and compresses the value. Next we have an encoder. The digitization of analog signal is done by the encoder. It designates each quantized level by a binary code. Encoding minimized the bandwidth used. Next is a regenerative repeater. This section increases the signal strength. The output of the channel also has one regenerative repeater circuit to compensate the signal loss and reconstruct the signal and also to increase its strength. Next, a decoder. The decoder circuit decodes the pulse-coded waveform to reproduce the original signal. This circuit acts as a demodulator. And lastly, we have reconstructive filter. After the digital to analog conversion is done by the regenerative circuit and the decoder, a low-pass filter is employed called as reconstruction filter to get back the original signal. Hence, the pulse code modulation circuit digitizes the given analog signal, codes it and samples it and then transmits it into an analog form. Next topic is sampling. Sampling is defined as the process of measuring the instantaneous value of continuous signal in a discrete form. And sample is a piece of data taken from the whole data which is continuous in the time domain. The following diagram shows the continuous time signal and sampled signal. Next topic is sampling rate. To discretize the signals, the gap between the samples should be fixed. The gap can be termed as a sampling period Ts. Hence, sampling frequency is equal to 1 by Ts is equal to Fs, where Ts is the sampling time and Fs is the sampling frequency or the sampling rate. The sampling frequency can be called sampling rate, which denotes the number of samples taken per second or for a finite set of values. Next topic is quantization. Quantization is the process of converting a continuous range of analog signal amplitude into a discrete set of values. Process of quantization. The following figure represents an analog signal. This signal to get converted into digital has to undergo sampling and quantizing. The quantizing of an analog signal is done by discretizing the signal with a number of quantization levels. The following figure shows how an analog signal gets quantized. The green line represents the analog signal while the pink one represents the quantized signals. Both sampling and quantization results in the loss of information. The quality of a quantizer output depends upon the number of quantization levels used. The discrete amplitudes of the quantized output are called as representation level or reconstruction levels. The spacing between two adjacent representation level is called as quantum or step size. The following figure shows the resultant signal, which is the digital form of the given analog signal. This is also called as staircase waveform. Next, types of quantization. There are two types of quantization. Number 1, uniform quantization. The type of quantization in which the quantization levels are uniformly spaced is termed as uniform quantization. Number 2. Non-uniform quantization. The type of quantization in which the quantization levels are unequal and mostly relation between them is logarithm is termed as a non-uniform quantization. There are two types of uniform quantization. Number 1. Mid-rise. In this type, the origin lies in the middle of a rising part of the staircase like graph. The quantization levels in this type are even in number. Number 2. Mid-trade. In this type, the origin lies in the middle of a trade of the staircase like graph. The quantization level in this type are odd in number. Next topic is quantization error. The difference between an input value and its quantized value is called as a quantization error. Here is a diagram of original and quantized signal and quantization error. Next, quantization noise. It is a type of quantization error which usually occurs in analog circuit audio signal while quantizing it to digital. For example, in music, the signals keep changing continuously, where a regularity is not found in errors. Such errors create a wideband noise called as quantization noise. The last topic is signal to quantization noise ratio, SQNR. The signal to quantization noise ratio is defined as the signal power by noise power. SQNR in decibels is equal to 10 log 10 S by N, that is less than or equal to 10 log 10 3 into 2 to the power 2V, that is less than or equal to 4.8 plus 6V in dB. So that is it for my presentation. Thank you.